We are talking about circular motion. We're continuing to talk about circular motion, and one of the things that really led to the development of this in the first place is the idea of planets orbiting. Okay, so Kepler figured out that it's all about ellipses. Okay, so what he said was that planets orbit around the sun along ellipses with the sun at one of the foci. Okay, so it's really all about ellipses. For the sake of what we're going to do, we are going to say that actually an ellipse is basically, if I take my two foci and squish them together, I get one foci, second foci, I get a circle. So a circle is a type of an ellipse, and it's much simpler for us to deal with than an ellipse. So we're simplifying ellipses down to circles to introduce the topic. Okay, now so Isaac Newton came up with an equation for the force between gravitational force. I'm sorry, I should have thrown that back up there. Okay, and the equation that he came up with was F equals G m1 m2 over r squared. And then this guy Cavendish determined that G has a value of 6.67 times 10 to the negative 11th Newton meters squared per kilogram squared. And that is the universal gravitational constant. At least we hope so. We sincerely hope that basically that G is the same at all points in the universe. If it's not the same in all points in the universe, we have some thinking to do. Okay, so right off the bat we can figure out something. So right off, I can use some numbers that I have off the top of my head. I could look some other numbers up, but I'll just use the numbers that I have off the top of my head. Okay, I have that the mass of Earth is going to be 5.98 times 10 to the 24th kilograms. The mass of the Sun is going to be 1.99 times 10 to the 30th kilograms, and that the radius between the Earth and the Sun is going to be 1.55 times 10 to the 11th meters. So now this allows me to calculate the force between the Earth and the Sun, so I can say that the force is going to be 6.67 times 10 to the negative 11th Newton meter squared per second squared. The mass is going to, mass 1 is going to be, we'll say that's the Earth, 5.98 times 10 to the 24th kilograms. Mass of the Sun is going to be 1.99 times 10 to the 30th kilograms. And we're going to divide by 1.5 times 10 to the 11th meters. And then, please don't make me say it, remember to square it. I can't tell you how many times people will be like, I didn't get the right answer. It's like because you forgot to square the bottom. Okay, so now here's where you want to pay attention. We're going to do this all in one shot. One shot. So I'm going to go through this slow. 6.67 second EE negative 11 times 5.98 second EE 24 times 1.99 second EE 30 divided by parentheses 1.5 second EE 11 close parentheses, square it. Now I've got it all laid out. Bam! 3.5 times 10 to the 22nd newtons. Okay, so, and then what we're going to do in the next video is we're going to talk about GPS satellites and how to use, and we'll sort of go through and develop how to figure out their orbit, and we might get that done in 10 minutes, or it might take a couple videos. But right there, this is just a really simple equation, gravitational force between two masses, and you basically just plug in the numbers and you get a mass, or you get a force.